All right, we're going to start here first. Just, you're not writing anything right now. I will tell you when you're going to write. So we're just going to start here talking about matter and energy. Have you talked about energy yet? Not at all? Well, tell me what's matter. What's matter? Has a very specific definition for it. I even had a song there for you. It takes up space and has mass. Matter is anything that has mass and takes up space. So let's still just look at this because we can talk about energy and matter. We can do this. So just looking at this, it says, what will happen when water boils for a long time in a tea kettle? Just tell me what will happen. Don't try to be scientific about it. Just tell me. But it boils, okay. But we said it boils, what will happen? That's why I want to know what happens in result of it boiling. The water will turn to steam. All right. So the energy is what? Well, let's say this. What is the matter? What's the matter in this sentence? The what? Water. The water. What's the energy? The heat. Heat. Energy is not matter. It does not have mass and it does not take space. Energy is going to be in the form of, you just told me, heat. What else can it be in the form of? Air. When there's heat, you also see what? So most of the time you see what with it. Like if you, now listen. If I light something on fire, that fire is going to produce heat in addition to what else? Light. Light is also a form of energy. If I light wood on fire, anything on fire, you are going to see, you are going to feel heat, you are going to see fire, and you may also hear something. What is it? You may hear some crackling, some sizzling, some popping. If you heat something up, you may hear some bubbling. So energy is also in the form of sound. So it's light, heat, and sound. That's going to be the form of energy. Got it? Yes. That's energy flowing, and that's how it produces the light. Yes. All right. So here we have the energy is the heat. The matter is the water. Notice that I said energy is not matter because it does not do what? Energy is not matter because why? It does not have mass and it does not take up space. You cannot get the mass of light. Light is not going to take up any space. We do this, it's not moving light out the way. All right? And for someone said steam, it can't be steam because steam is water. It's just in another state. It's in the gas state, and that is matter. All right, let's do this one. What will happen when dry wood is added to a small flame? Just tell me what will happen. Joel. What's going to happen to the wood? The flame will get bigger, but what happened to the wood? It's going to light? You don't know what happened when you put wood in fire? You said it's going to light. What will happen if you put wood in fire, guys? It's going to burn. You've all seen wood burn before. What is the energy? The heat. Good. What is the matter? The wood. Very good. What will happen when a fast-moving river rushes through a rock channel? Now, what that means is, for instance, how many of you have ever had a water hose, and maybe you were playing with the water hose outside with your friends, or maybe you were watering the grass, or maybe helping your parents or someone wash a car? Okay, now if you turn the water up really high and you put your thumb over the front, what's going to happen with that water? It's going to squirt out really hard, really fast. And if you put the water on the sidewalk where maybe there's dirt or grass, what is it going to do or leaves? What is it going to do to those leaves? It's going to push those leaves further down, okay? So what's the energy? Pressure. The energy is pressure here. And what's the matter? The water. All right, we'll do one more. Let's see which one I want to do. All right. What will happen when well, I can't read. What will happen when the glass full of iced tea is left sitting in the sun? Okay. It will evaporate. Well, first it will do what though? Melt, and then the ice will melt, and then the liquid will evaporate. All right. So the energy is what? Heat from the sun. But you can't say the sun because the sun is matter. All right? But what is the matter? What's the subject of the statement? The iced tea or the liquid. All right, good. All right, so let's move on. Still not writing. This is just review. Matter is anything that has mass and takes up space. Very good. Matter can have many different characteristics. What's a word that you can use for characteristics? You talk properties. Matter can have very different properties. All right? Okay? Matter's properties are used to classify matter. What does that mean, classify it? We talked about classification when we talked about the squid and all those things, kingdom, phylum, order, all of that stuff. What does classify mean? To identify in its right place. So it's you are classified as 8th graders. And if you're in the hall of 4th graders, then you're in the wrong spot because you are classified 8th graders. All right? So matter's properties are used to classify matter in much the same way that the characteristics of living things are used to classify organisms. Like we talked about in class, we know that we are mammals. We do not belong to the dolphin family because we have been classified as mammals. Chemistry, which is what we're talking about now, is the study of properties of matter and how matter changes things. This is actually what chemistry is, and this is what we're doing. So this is your introduction to chemistry once again. All right. Still some review. What can't we see when we look at it? We can't see air, but is it matter? It is matter because why? It has mass and takes up space. Even if I'm standing here right now, everyone put your arms out and do the bird. Whoop, whoop. Whoop, whoop. That was an old dance from that Prince and Morris they used to do. Anyway, so are you telling me that the air is there even though when you're moving your arms up and down? How do you know? You can feel it. What's happening to that air? Your arms are pushing it out of the way. Very good. So any questions about that? All right. Can I get a reader? Go ahead, Makai. Read it loud.
Even though there are only 115 or so different types of atoms, there are thousands and thousands of different materials that we interact with every day. Think of all the different substances as that you eat, drink, breathe, drive, write with, write on, sit on, and stand on, store stuff in, whatever. All of these things are made of atoms. Let's take a closer look at what these atoms are.
Okay, so this is just a furthermore introduction to chemistry just to help us better understand. Pictured below are a few common items. We're going to click on some of the items and identify what's going on with them. We do know that Exhibit 1 is a penny. Exhibit 2, water. Exhibit 3, a balloon. So we're going to click on the penny. Everyone say abracadabra. Abracadabra. All right. We could use a magnifying glass to take a closer look at the penny, but we would still not be anywhere close to the level of the atoms in the penny. We can identify the penny, look at it. We would have to go deeper with an electron microscope to be able to look a little bit closer and zoom in so we can take a closer look. Everyone say abracadabra. Abracadabra. When we zoom into the penny, we now know that the penny is made up of certain atoms. It's made up of an atom. So when we get closer to the atomic level, first of all, the atoms are the same. Notice they're all the same color. They all look the same. Whenever a substance is made of only one type of atom, we call that substance a element. Who knows the element that a penny is made up of? Copper. And they used to just be made of copper. Now they're made up of copper and zinc, but for sake of argument, copper. Now, could someone explain to me why these atoms are moving? So you're telling me that when a penny sits on the table, it's really moving? Huh? No. The reason why this is showing you that it's moving is because we are never at absolute zero. Absolute zero would be 0 Kelvin. So because we're not absolutely frozen, atoms do move. We just can't see them. They move so slow that you cannot see them moving. The penny's not moving, but the element that it's made of, the particles are moving because we're not frozen. If we were frozen at absolute zero, everything would be frozen, which means we would be dead. All right. So in this case, like you told me, the penny is made up of copper. The other thing that we should take notice is how the atom's behaving, which is just what I told you. The atoms are jiggling around, but always stuck in the same position. And because it's a solid, even though solids are solids and they're harder substances, those atoms are still moving because we are not at absolute zero. Elements are also called pure substances. Someone tell me what pure means. And we have the same people raising their hand. I know the rest of you know what pure means. This is not rocket science. So I'm not asking anything that you should not know. Jedison, tell me what pure means. You can't give me the same word. So what does pure mean? It's not like what? Say it again. Nothing's added to it. Very good. So elements are pure. There's nothing added to it. They are exactly what they are. And it's the smallest piece, and it's the smallest type of matter. All right. That's it for the penny. Everybody say bye, penny. Bye, penny. All right. Let's take a look at the glass of water. Abracadabra. Abracadabra. Again, with the magnifying glass, we can't get a close look there. So everyone say your magic word. Abracadabra. So we want to be able to zoom in on our glass of water so we can take a look at what the water is made of. Notice when we look at the water, it is not made up of one substance. It's made up of two. There's red and there's white. Even though there's two white pieces connected to a red piece, we know that it's made up of two substances. What are those two substances? Hydrogen and oxygen. How many hydrogen? Two. And how many oxygen? One, because it's H2O. All right. So we look at it and we know that they're chemically joined together. No one can make water. It's chemically joined together. We take hydrogen and we take oxygen. Hydrogen is a gas. Oxygen is a gas. We put it together and we get a liquid. You get a new substance. So that's a chemical change. And this is now called a molecule. If we look at this, you just told me this is hydrogen and oxygen. So which one do you think is hydrogen? Joel. The two white ones, because there's two hydrogens, and obviously oxygen would be the O. I mean, the red one. I said the O. And this just explains exactly what we talked about there. This is a compound, just like a compound word, hot dog. That's a compound word. It's two words put together. This is a compound because it's two elements put together, two or more. A compound word could be two or more words as well.
Alright, so technically, if you freeze like a glass jar and then like you let it like thaw or something like that, wouldn't it kind of make
It's not making water. You're talking about if you freeze a jar? No, it's the condensation of that lays on the jar that the water. It's not making water. Because when you put the glass jar in the freezer, the glass jar is warmer than what the freezer temperature is. So the warmth that's on the glass jar, that air, the coldness or the steam or whatever that's in the refrigerator of the liquid is it's cold, it's frozen. But once that air settles onto that jar, it's going to heat up. So that makes that liquid, which then refreezes it because it's in the freezer. It doesn't make a liquid, it's already there. Just like when you capture steam in the air and you do like this on your hand and you feel it, it's kind of moist. You didn't make liquid, it's there already. It's just that it's condensed. It went from a hot temperature to a cooler temperature. Okay? Good question. All right. So does everyone understand compound? Yes. Okay, we're going to get deeper into that a little bit later. All right. Notice how those molecules are moving. Are they moving faster or slower than what the penny was, Jaden? I'm going to move you.
Slower than what the penny was. Faster.
They're moving faster than what the penny were. They were closer together. And they were closer together because it was a solid. These are freely moving a little bit more because it's a liquid. All right.
Liquid.
Now to the balloon. Everyone say abracadabra. All right, again, we cannot get close enough to it with the magnifying glass, so we have to go deeper. Before we do that, does anyone tell me how they think the molecules in the balloon are going to move? Huh? Out. Well, you mean the water was moving kind of outwards. They're going to move faster. Are they going to be more freely? Yeah. Why? Because it's a... No, because what's in the balloon? Air, which is a solid, liquid, or gas? Gas. Which is a gas. Before I go deeper, tell me, how do you think that the molecules are going to be organized? You think it's going to be all of one of the same molecule? One of the same, molecule? Maybe two or more molecules, or a whole bunch of different molecules? Multiple. What do you think What do you think comes out when you breathe out like this? Do you think it's just pure? No. Is that just oxygen? No. Okay, and but what else comes out when you breathe out besides oxygen? What other element? So a little bit of carbon dioxide comes out. How do we know? Because we also breathe it in. What else is our body made of? I told you that we did a cycle. What other element starts with an N? Nitrogen. Okay. So we'll take a closer look. Like we said, it is moving fast. It's all over the place. You see some blue molecules, some gray and red, just red. So when we look closely, we see that there's 3 different types of molecules pictured there, and they're moving quite fast. The most common molecule is the 2 blue ones. What do you think this is, the most common? The common molecule, common air molecule. It's right here. Nitrogen. The molecule is nitrogen. It's made up of 2 nitrogen atoms. And we'll talk about these elements later and how we write them when we get later into chemistry. Then you see something that looks like this. There is another molecule in the balloon. Looks like this. What else do you think we breathe out? Carbon. Just carbon? Carbon dioxide. Which one do you think is the carbon? The gray one. What does the word di mean? 2. So dioxide. That's dioxygen. So it's 2 oxygen. So there you go, CO2. And then lastly, oh wait, let me go back because that is considered a compound. Why is it a compound? It's 2 or more elements put together. All right. And then you have oxygen, which we know so familiar that we used to think before we were smart enough to know that that's not the only thing we breathe. All righty. So we're going to move on. This is considered a mixture. Why do you think it's a mixture? I'm not going to the bathroom right now. Because it's different types. More stuff is mixed in there together. And they're not bonded together. You have some nitrogen thrown in there, some carbon dioxide thrown in there, and some oxygen thrown in there. And it's not all together forming something new. They keep their own identity and they're just mixed all together. There was no helium in there. This person is blowing it up. We don't have helium inside of us. When you blow up a balloon, you can't hold it up in there. You have to go to a helium tank to do that. Good question, though. All right. Yes. Helium is lighter than air. And when we get into the periodic table a little bit more, you'll see that. It would fill up the balloon, but oxygen is part of the air. It's not lighter than the air. Because it's lighter than air. All right. You have a note sheet that looks like this. We are going to be filling in the blanks as we go through our note sheet. You should see that it says types of matter. So at the very top of your tree chart, it is matter. This is the tree chart. So it's like a family chart. It's like, for instance, if we were talking about your family, for instance, if this was the Wiggins family, it'd be Wiggins. That would be the family. Then we would have grandma and grandpa. and then you would break down to their family. All right? Or not, wouldn't be grandma and grandpa. Maybe it might be a brother and a sister, and it would break down their family and how that works. Everyone see that? Okay, so this may be the brother, and then the brother may have 2 children. This may be the sister, and the sister may have 2 children, and then those children have children, things of that nature. So this, don't look at this chart as, okay, this is a family chart. That's just how it works. All right, so you have this in front of you, and you're going to be filling in blanks as we talk. It's front and back. So looking at the chart, matter can either be a substance or a mixture of more than one pure substance. So when we look at these words here, next to them, these are the definitions that belong to that box. For instance, this says, this box is one in which all the particles are the same. What do you think belongs there? And this one says, when all of the particles are not the same, it's going to be either this or this, substance or mixture. What do you think substance goes? Here? Okay. Yes. So make sure you fill in the blank. A substance is one in which all the particles are the same. So if something is a substance, you're going to have all of the particles are going to be the same, like that penny. When all of the particles are not the same, that's considered a mixture. Make sure you fill that in. We good? All right, so let's talk about an element. We said that an element is a what? What type of substance? Jadison told us what that word meant. It's pure. What does it mean by pure? Nothing has been added to it. Good. So you're not writing anything yet. A pure substance that cannot be separated into simpler substances, meaning that there's nothing there. You can't separate it by physical or chemical. You can't break it and it becomes something else. You can't set it on fire and it becomes something else. It is pure. It is what it is. If you melt it, it's going to be the same thing. For instance, copper, which is Cu, oxygen, O, nitrogen, which is N. Any questions? Okay. We're not writing anything yet. A compound, like we said, like a compound word, it's a substance made of 2 or more different elements that are joined together by a chemical bond. It's not like you put like the balloon where they're just all floating around. You put it together chemically. So if you put carbon and oxygen together, you're going to get carbon dioxide or carbon monoxide, which is deadly. If you put sodium and chlorine together, you're going to get salt. That's a chemical. It's a compound because they've been put together. And the only way you can separate them is by chemical means. So it's 2 elements put together, 2 or more, and you can only separate them by chemical means. That is also a substance. And like I said, here are some examples. Salt would be NaCl, which is sodium chloride. Rust is also a compound, and that's iron oxide, FeO2. And carbon dioxide is CO2. All right? What is a mixture? Somebody raise your hand and tell me what a mixture is. Samaje. 2 things put together? You got to be more specific because you have to be more specific because a compound is also 2 or more things put together, but it is chemically put together. You have to tell me more information about a mixture. It can be 2 or more things put together, but you have to tell me how are they put together. Physically. And can it be separated physically? Yeah. Does it make a new substance? No. So unlike an element, all particles in a mixture are not the same. They're just a bunch of different things placed in there. It is not a compound because you can separate it physically. It keeps its individual identities. Each substance in a mixture is not always the same ratio. There may be a little bit here, a little bit there, a lot there. So, for example, arroz con gandules, which is what I had for dinner, rice and beans, yesterday, that is a mixture. You still have beans, you still have rice. It has not been chemically put together. My brother picks his gandules out of there. So he can take them all out and still have his rice. If it was chemically put together, he would not be able to pull the beans out. Another mixture would be like when you go trick-or-treating and you throw all your candy in a bag. You can take out your Reese's, you can take out your Twizzlers. It's not chemically put together. Kool-Aid is a mixture, yes. All right, here's where we get a little bit deeper into 8th grade. We have something called homogeneous mixture, and I'm going to need you to be very mature. The root word there, or one of the root words there, is homo. That means same. Genius means that it's together. So it's something that's together, meaning that you have a mixture that contains more than one type of matter, and it's the same throughout. You can't see the difference, like Kool-Aid. It is a couple of things put together. You can physically separate them, but when you put them together, you can't see any difference. You don't know what part is the water. You don't know what part is the Kool-Aid. Like, for instance, if you mix water and pancake batter, once I mix it together, I can't see the water. I can't see the pancake batter. Is this making sense?
Yes.
Okay. So it is still a mixture, and it's not chemically put together. Soda is a mixture. It has a bunch of different things in it that has just been mixed together, not chemically. Milk is a mixture. Chocolate is a mixture. And everyone take a deep breath. You just breathe in carbon dioxide, oxygen, nitrogen, some dust, all of that stuff. It is a mixture. Yes. Salt water is a mixture. Yes. Very good. All right. Then we have something called heterogeneous mixture. Hetero means different. So this is a mixture, and someone see if they can give me the definition of, since I gave you what homogeneous mixture or homogeneous mixture is, someone see if they can give me the definition of heterogeneous mixture if I'm telling you that hetero means different. This is where you have to think. Jaden, I'm expecting you to be thinking and not playing. See if you can give me the definition. Come on, guys, I need you to try to use your brain. Don't wait for me to give you something, because when you get grown, I'm not giving you no money. Talia. Talia. What do you mean same type of mixture? It's made up of different things, and you can see the differences because it's different things. So it contains more than one type of matter, and it's different throughout, meaning that you can see the difference. Give me an example. A fruit salad. You can see the tomatoes. You can see, don't put tomatoes in the fruit salad. You can see the strawberries, the grapes, the melons. Cereal. You can see the milk. You can see the cereal. Pizza. You can see the pepperonis and the cheese and the dough and the sauce. Ramen noodles. What's mixed in there? And the ramen and the water. Silly. All right. Soyo, oatmeal, blueberry oatmeal, eggs, chocolate chip cookie, fruit cake. Definitely can see the difference in there. All righty. Now here's something called suspensions. It doesn't mean like you're suspended, although we can develop a definition from that. If you are suspended from school, you are then what? You are taken out of the school. So therefore, you have mixtures where it is all mixed up, but there's something that is suspended. It's floating. It's out of the substance. It's not taken out of the substance, but you can kind of see it floating throughout the substance. So it doesn't totally mixture. The particles are dispersed, like the liquid or the glass, and it's settled out. It may settle down at the bottom, but when you shake it up, it'll float around and then settle out at the bottom. It can be heterogeneous or homogeneous, like a snow globe, and like soup. All right? Lastly, you have a colloid. So colloidal mixture, sometimes these are things you don't know if they're a solid or a liquid. Like, it's kind of like a liquid, but it's not a liquid. I really don't know what that is. So it's a mixture that has particles that are dispersed throughout, but they're not heavy enough to settle down. So it doesn't become a solid, but it's not quite a liquid. What types of things are those? Makai? Yeah, an example. Nope, a rock is a solid. This is a substance, a mixtured substance, a mixtured thing that you can't really identify it as a liquid or solid. Maybe things that you use in everyday life. Toothpaste would be a good one. Peanut butter is a good one. Jello, excellent. Jelly. Gummy bear is a solid. So, Jello, ketchup, mustard, whipped cream, butter, hair gel, those types of things, you can't really classify them as a solid or a liquid. Mayonnaise, yes. All right, back to our notes. So, what things that we just talked about would be considered substances? It's made up of which was one in which all the particles are the same. What would be substances? We talked about two things. Talked about 4, 5, 6, but two of them would be substances. Look at the definition, guys. Is one in which all the particles are the same. We talked about elements. We talked about homogeneous mixtures. We talked about heterogeneous mixtures. We talked about if it's a homogeneous mixture, the particles are the same, but we have mixture. You think mixture, a homogeneous mixture is going to go here when we're talking about mixture here? No. So anything that's a mixture is not going to go over here. It's going to go over here. So what other things do we have left that could go there where it's one and the same? The particles are the same. We talked about a compound, element, homogeneous mixture, heterogeneous mixture, colloid, and suspension. Which would be made up of say it louder, element. Thank you very much. We talked about another type of substance where it is chemically put together and it's a compound. Some of you are not using your brain. Now we have two types of mixtures. What were they? Homogeneous and heterogeneous. But we can't write them just anywhere because they have families that come from them. So we have to decide where we're going to write them. And I'm just going to put it up here for the sake of time so we can get through. Heterogeneous will go here. Homogeneous or homogeneous, however you say it. Archie's, turn around. You don't have time to play. A colloid is a homogeneous mixture. Someone tell me why a colloid is a homogeneous mixture. What are some colloids? What did we say some colloids are? Ketchup, Jello. So why would that be a homogeneous mixture? No. It's the same throughout. Ketchup, you can't see everything it's mixed with. It's the same throughout. So what would be a heterogeneous mixture? Suspension. You could separate it, but suspensions also can be homogeneous in some cases. Okay? You good? Are we all good? All right. I'll get you caught up, Jihad. At the bottom of your paper, if you're using a pencil, I want you to take out a pen too. If you have, no, don't even worry about that. We'll do it another way. All right. Notice that your element is pure. It is pure without. It's not made up of anything else. So that's why it's shaded all gray. You see it on your paper? And there might be a little speckle of white. Just shade that in gray so you see that it's all pure. It's listed as what letter? What letters are there? Cl. What is that? Chlorine. Chlorine. Very good. That's an element. It's pure. It's not made up of anything else. Here you have a compound. Compounds are made up of two or more elements. So for this compound, this is carbon dioxide. Fill those in. So you can see it's two or more elements. You have carbon and you have oxygen. You can color this middle one in, but leave the other two white so that they look the same, and then the middle one looks different from those two. So now you have elements build compounds. When you start putting compounds together, you can get mixtures. A homogeneous mixture would be one that's what? Homogeneous. The same throughout, meaning you cannot pick out little things. So go ahead and shade that box in as well. But we're not going to label it with an element because it's not an element. It's not pure. It has other stuff mixed in it. Ketchup has vinegar and tomatoes and salt and a bunch of other stuff that's in it. So just lightly shade it in, and then we'll move on. Now a heterogeneous mixture means what? You could separate it. So let's go ahead and draw some things here. Maybe draw a circle in there, star, a rectangle. Oh, that was a square. A rectangle, a couple of dots. When I show my box, it's going to have some colors, but I'm just showing that it's different without. You put your shapes in there. So notice you can see the blue, you can see the green, the purple, the pink, the yellow. It's different throughout. You can kind of identify those things throughout. Remember my example with the rice and beans. Any questions? Okay. Then I believe you're turning your paper over. But first, let's just see if you can tell me now. Here, we have all of this candy. What would this be considered? A substance or a mixture? Mixture. Raise your hand. What kind of mixture? Aaliyah. Heterogeneous mixture. Why? Someone help her out. Why? Jayla. We can see the differences throughout. You can pick them out. All right. What about this is water and sugar. What is this? A substance or mixture? Mixture. Raise your hand and tell me what kind of mixture. Raise your hand. Makai. Homogeneous mixture. Someone tell me why. Erica. Because it's the same throughout. You cannot pick the salt out of there. You have to boil it out or let it settle. All right, what about this here? Is this a substance or a mixture? Substance. What kind of substance? Element. What element is it? Zinc. Very good. All right, moving over here where you have salt, C12H22C11. Would this be a substance or mixture? Makai. Help him out, Talia. Substance. What kind of substance? Jaden. What kind of substance would sugar be? Compound. Why is it a compound? Katoria. It's chemically mixed with what? More than one element. Two or more elements. What about H2O? Is that a substance or mixture? Substance. What kind of substance, everyone? Compound. Why? Kylie. With two or more elements. Very good. Any questions? Okay, good. All right. Mixtures versus compounds, so you know what they are. Under your box for mixtures. It's made of elements and compounds and other mixtures. So let's say if we had sugar water with the penny, that would be a mixture. It would have sugar, C12H22, C11, plus a penny, which is copper, plus water, which is H2O. And maybe you threw some dust in there, which is another mixture, because it's been sitting out. C6H22O11 is sugar. A compound, however, is made of elements, and only elements. In that box for compound, put something like H2O. In the mixture, put water and sugar and dust. Maybe it's sat out. A mixture, there are no changes in the original properties of the components. So in other words, things stay the same. I want you to write that, no changes in the original properties of the components. But when I say things stay the same, it means you still have sugar, you still have water, and you still have dust. It did not become pudding, or it did not become oxygen. In a compound, however, what happens? Is the properties originally the same? No, what do you have now? You have a change. It changes the original properties in the components. So for instance, hydrogen plus oxygen equals water. Hydrogen was a gas, oxygen was a gas, now it's a liquid when you put them together. Is this making sense? Okay. All right. Mixtures can be separated by physical means. So you can physically take it apart. We boiled it, which means we would try to evaporate some things. We can pick it out. However, compounds have to be how? How can compounds be separated? Only chemically. Lastly, mixtures are formed using any ratio of components. You don't have to say, I'm going to put a teaspoon of dust. I'm going to add a 2 molecules of hydrogen with the water. You don't need it. You just throw it all together. But what about compounds? Does compounds have a ratio? In order to get water, you have to have 2 hydrogen and 1 oxygen every single time. In order to get carbon dioxide, you have to have 1 carbon, 2 oxygens. So it's formed using a set ratio of components. Questions? Okay, I'll give you a minute to finish this, and then we're going to move on. Something a little bit more fun. Yes.
I never knew, like, you know how like water is like oxygen. I never like understood
Mhm. But that water is one of the naturalist purest substances there is. It's not made, so we can't say how it's just there. It's because it's natural. But we could chemically separate it to see that it's made of hydrogen and oxygen. It's called electrolysis. All right. Just a little bit of review before we move on to your other paper. You're not writing anything. You're done writing for right now. All right. Types of matter. We're going to classify the following as an element, a compound, a mixture, whether it's a heterogeneous mixture, which would be HETM, or homogeneous mixture, which is HOMM. If it's a colloid or a substance. For sulfur, raise your hand. Sulfur, raise your hand and tell me. Odell, what is sulfur? Sulfur S, what is it? Compound? I only see one letter S. Help him out, Jettison. Element, very good. Muddy water. Element, compound, a type of mixture, colloid, or substance. Talia. Homogeneous mixture or homogeneous. You can say it either way. Why is it a homogeneous mixture, Amira? Homogeneous? Mud? It's the same throughout. You can't pick anything out of the muddy water. Gravel. What is gravel? Maya. Gravel's down there. What is it? Is it a mixture, an element, a compound, a colloid, or suspension? Is gravel an element? Okay. Is it a compound? Is it a mixture? Don't tell her. That doesn't help nobody. Is it a mixture? Is it a bunch of rocks thrown together? Okay, so is that a mixture? Okay, what type of mixture though? Heterogeneous mixture. Good. We can pick out the different rocks. Mercury, Hg. Michaela. Element. Very good. Table salt, NaCl. What is that? A compound. Any questions? Okay. Another one. Water. H2O. Jaden, what's that? Good. Plain oatmeal. Erica. Homogeneous or homogeneous. Vinegar. Actually, vinegar is a compound. It's acetic acid. It's a compound. But you wouldn't have known that. It's made up of, it's a bunch of different elements, and that's it. Oxygen. Artrice. Listen, when you whisper the answer to that person, number one, it's not helping you. It's not helping them. Oxygen. Artrice. Element. Mustard. Samaje. It's a mixture, but what type of mixture? Well, it is the same throughout, but then we have, it falls under another classification. Remember, you don't know if it's a liquid or a solid. Talia, help them out. Colloid, very good. All right. What have you learned? Number one, I pull your number. Tell me what's matter. Number 16. Somebody, you did take the attendance up, right? Who who was absent? Just Passion and Savani, Kanisha, Jaden Cotman. Okay, number 16. Matter is.
It is oh my god. It's, I know what it is. I know it.
How many of you listened to my song that I had?
What
I have to play it later. I played it before I left when Miss Nagana was teaching you. I played the song for you all. And I think I gave y'all lyrics. And has mass. Very good. Examples of a pure substance. This is for number 5. Joelle, examples of a pure substance. Water is not a pure substance. Nope, because it is mixed with hydrogen and oxygen.
Oh, okay. Air.
Air is not a pure substance. We just said it had carbon dioxide, oxygen, dust. Pure substance, Antasia. Sulfur. Any of the elements are your pure substances. Chlorine, very good. Mercury. An element is number 4. Titan. What's an element? An element? What's an element? You guys just did projects on it. What's an element? Is it made up of more than one thing or just one thing? So that means it's what? An element? One thing. So it is. If it's only made up of one thing, you can't add. It's not. Nothing's added to it. It is. Jadison gave us the word. It is what? Pure. All right. A compound is number 28. Guys, y'all shouldn't be passing papers around. Sit down. 28. We don't have a 28 in here. Number 18. This is for Jemiah. A compound is. Nope, I'm sorry. Jaden is 18. I apologize. Jaden, what's a compound? Just think of a compound word. This is from 3rd grade. Jaden. You think it's called what, Makai? Huh? 2 or more. What are things, though? You can't say things. That's a mixture. 2 or more elements mixed together and chemically removed. All right. Get your next page that looks like this. This is your types of matter song. Did you want me to play the other song first or this one?
This one, the other song.
Okay. Actually, what I'll do is I'll send a reminder with the link for the other song, Remind 101. I'll play this one now because y'all got stuff y'all got to do. Now, it'll be homework if y'all don't finish it. Wait a minute. Let me explain this. All right. So here you have the lyrics. You're going to be looking at the lyrics. Underline while you're listening to the lyrics and you're reading through the lyrics. Samaje, pay attention to what I'm saying because you will not hear me if you're not paying attention. Look up at me. As you're listening to the song, be sure to underline things that seem important in the song, information that you think the song is giving you, and then we'll move on to our next portion for looking at the song. So, and this is on YouTube with the lyrics as well. God bless you. Bless you. You know I'm not a rapper, though, right? T-Dubs. You said what's my name? Oh. Elements are simple things that can't be broken down. When put together chemically, they always form compounds, But the way the chemicals are found, it's jumbled up in mixtures that most chemicals are found. Elements are building blocks from which all things are made. Over 100 elements, in this elemental array. And they're all made of atoms. John Dalton said so. Elements, just pure and simple. Elements are simple things that can't be broken down. Found in many places. All gold is underground. I'm gonna do this money dance. Are everywhere, one of life's permanent fixture. Chemicals really matter. Elements, compounds, and mixtures. Chemicals are everywhere. It's one of life's permanent fixtures. Chemicals really matter. Elements, compounds, and mixtures. Say it 4 times. Chemicals really matter. One of life's permanent fixtures. Chemicals really matter. Elements, compounds, and mixtures. Compounds form elements. And though it may seem strange, when they form a compound, their properties all change. As chemicals combine, their particles rearrange to form different substances. Their properties all change. Are everywhere, one of life's permanent fixtures. Chemicals really matter. Elements, compounds, mixtures. Chemicals are everywhere, one of life's permanent fixtures. Chemicals really matter. Elements, compounds, mixtures. Chemicals are different. There's one thing you bet. Mix salt and water. It's just salty wet. You might think there's change. Just 2 compounds mixed. No chemical combo. There's nothing new. There is nothing new. There is nothing new. Nothing new. There is nothing new. There. Nothing new. Chorus, chemicals are everywhere. One of life's permanent fixtures. Chemicals really matter. Elements, compounds, mixtures. Chemicals are everywhere. One of life's permanent fixtures. Chemicals really matter. Elements, compounds, mixtures are everywhere. All right. So now if you flip your paper over, you notice that these are the comprehension of the song. Again, like I told you before, with any song that I make, it's not important unless you know how the song can help you. You can rap it all day long, but if you don't know what it's going to do to help you, then it's no good. So therefore, we need to break this song down. So you read the song on the other side of the sheet, and we listen to the song. Now we need to answer the question. So what you're going to do by yourself right now, you're going to work through these questions. Try to look at your song, break it down, and what you do not finish is going to be homework. Tomorrow I'm going to expect for it to be done so that I see that you have a full understanding of the song.